This video is on conformations of cyclic molecules. Cyclic molecules are much less flexible than linear molecules, so the number of conformations is significantly fewer. Recall that sp3 carbons are tetrahedral. It's difficult to form small rings out of tetrahedrals. This results in ring strain. Three- and four-membered rings are referred to as small rings, and these have the highest ring strain. This is due to the large angle strain as well as torsional strain. Where is this coming from? Well, let's look at a three-membered ring. You will notice that the angles of a triangle, a three-membered ring, is 60 degrees on the inside when you want an ideal angle of 109 for a tetrahedral. Furthermore, if we look at the Newman projection, we see that all the hydrogens in this system are eclipsed. If we look at the four-membered ring, it's not as bad, but the hydrogens are mostly eclipsed still. Next, we have the 5, 6, and 7-membered rings. These are called the medium-sized rings. They have very little strain in them, and this is because most of the system has the ideal angles, and the hydrogens or any groups coming off them are staggered. Finally, as you go to larger sized rings, such as the 8 and 9-membered ring, you start getting folding into each other, so you start getting some other types of interactions that cause strain. As we can see, the 6-membered ring is the sweet spot where all the carbons are tetrahedral and staggered, and therefore there's virtually no strain. It's not a coincidence that you've been drawing so many hexagons as we've been drawing chemical structures. This is clearly the most stable state out of rings.